Okay, so before we start, just going to remind you guys that in your emails, you are usually sent invitations to join either lessons where I actually am doing calculations or office hours. Uh, I record the lectures and the lessons. I do not record the office hours. The office hours is just kind of a thing where you can join, come in and out as you want if you have questions regarding anything. So, what we're going to do today is I'm going to switch gears and start talking about the gases and how gases behave, because there's lots of stuff that you will deal with if you ever take college chemistry when it comes to gases. So when we look at gases, you kind of have to understand how they differ from solids and liquids, and allows you to calculate a whole bunch of things about them. So the main thing that gases have that liquids and solids do not is that they are compressible, or compressibility is the idea. And this is how much matter, the volume of matter, will decrease when you exert some pressure on it. So, for example, one of the reasons why an airbag is safer for your noggin than a windshield is that an airbag, even though it inflates very quickly and it does exert a lot of force on a person, it has a compressible gas inside, whereas a windshield, which is a solid, is not compressible. So this allows your head to come to a stop a little bit more gradually, even though they're very quick. And what that does is it exerts less force on you. So the reason gases are compressible is because they have empty spaces in between each gas particle. These little micro voids allow you to squeeze them together. Also, side note on gases is going to be important down the road is that the particle of a gas particle is very small when you consider the volume that it takes up. So, for example, if we took all the gas particles in this classroom right now and we tried to smash them as close as we could to each other, the volume that they would make up would be very small compared to the overall volume of the room. So, idea that you need to understand is that gases will always expand to fill their container. So, that's going to be an important factor down the road as well. So, gases are kind of tough to measure when it comes to masses or moles or things like that. So, in our world, probably the easiest way to measure a gas is to measure its pressure. If you have a flat tire or you have a low tire, you go and you put gas into it. A lot of times, the main measurement we use is pressure. So if you have a tire gauge, that's going to read in something called PSI, or pounds per square inch. What pressure is a force that's exerted over a given area. And we have lots of different versions of pressure that we will look at. You actually saw one the other day with the phase diagrams. I believe we used ATM on that phase diagram. That is a unit of pressure that is used in chemistry a lot of the times. So pressure is the force of something over area, and it's easier to measure things in pressure that are gases. There's two ways you can change pressure. You can change the force, or you can change the area. So, for example, if we just went out and stood on a thin ice on a lake, um, I could change my pressure on the thin ice one of two ways. One way is I could carry a very heavy weight. That would increase the force on the ice. The other way I can change my pressure is, instead of standing on 2 feet, I could stand on 1 foot. That would decrease the area and exert more pressure on the lake. So with gases, there are three things that we look at that influence gas pressure. These things are going to be important when we start doing calculations for these down the road. The first thing is that the amount of gas, and usually that amount is measured in moles. We use the lowercase n to designate the amount of moles. So moles of gas, think of it this way: when you pump air into a basketball, more moles of gas in there equals more pressure. The second thing is volume of gas. Volume is the only inverse relationship when it comes to pressure. I'll show you guys that in a little bit with the syringe. Volume, the volume of a container. And then the third thing is the temperature of a gas, and we use kelvins to measure gas temperatures. So you don't have to stress about it right now. If you don't know what a Kelvin is, we're going to teach you how to do that down the road. But right now, just think of high temperature, high pressure. All right, so we'll start with moles of gas. Why do moles of gas change the pressure? Well, if you add more particles of gas inside of a balloon, what happens is it will increase the pressure. And the main way it does this is that those little gas particles are running in to the container. They're running into the sides of the balloon. So each time that they run into the balloon, this collision exerts a little bit of force. If you increase the force on the walls of the container, in this case, the balloon, what's going to happen is it's going to increase the pressure. So they just think of it this way. Lots of these little collisions on the inside of the balloon are going to cause an increase in pressure. Okay. So when you deflate a basketball, you take that gas out of there, and because there's less gas particles, think there's less collisions. So moles of gas, right? The second one is going to be volume. Okay. Now with volume, like I said, it's the only one that is inversely related. So when you decrease the volume of a gas, it increases the pressure inside. So I'm going to go ahead and show you guys this with this syringe demonstration here, okay? So here's a syringe. We did this the other day. There's 60 cc's of gas in here. I'm going to close the top. And as I make the volume smaller, the pressure inside builds, okay? And as I make the volume bigger, the pressure inside decreases, okay? So that's kind of the idea when it comes to volume. We'll look at why that is. So when you decrease the volume in a syringe, the particles don't have to travel as far to hit the sides of the container. And what that's going to be, once again, is more collisions, more force, more pressure. Think of taking those little particles and cramming them into a smaller area. Because they don't have as far to go, they're going to hit the container walls a lot more, and it's going to exert more pressure. Okay? And so, like we said, with the syringe, increasing the volume will decrease the pressure. The reason increasing the volume decreases the pressure is because now those particles have to travel farther, and because they have to travel farther, there's going to be less collisions, which is going to be less force, which would be less pressure. Temperature is the last one that we're going to look at. Temperature, it looks at increasing the temperature of a gas will increase its pressure. And this has to do with speeding up the particles. Adding heat will speed up the gas particles. It increases a type of energy we call kinetic energy. Kinetic energy is the energy of moving things. So things that are big and moving fast have a lot of kinetic energy. Well, gas particles aren't very big, but they can move very, 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 very fast. So when we do that, and we get those particles moving faster, they hit the walls of the container harder, which means there's more force and more pressure. Conversely, if you cool a gas down, they're going to move slower, they're going to hit the sides of the container with less force, and there will be less pressure. Okay, so decreasing the temperature will slow the gas down. So those are kind of the main factors that influence pressure, and they're all related to each other. So what we're going to do for an assignment, and I'll post this on Classroom under the assignments, is you're going to predict how the gas would change with each of the following scenarios. So say we have a gas and we squeeze that gas, we squeeze a balloon. Describe how you think maybe the pressure would change inside that balloon if you squeeze the balloon. If you heat up an aerosol can, so an aerosol can has a compressed gas inside, what's going to happen to the pressure inside of the aerosol can when you heat it up? All right, you inflate a balloon inside and you take it outside on a cold winter day. So you inflate a balloon, you take it outside and it's really, really cold and you leave it in your car. How does the volume of the balloon change? You pump air into a basketball. So where you have a basketball that's deflated, we pump air into it. How would the pressure be affected? And lastly, you heat up a balloon and you squeeze it. So you heat up a balloon and you squeeze it. What's going to happen to the pressure inside? Like I said, I'll post these on Classroom, and this will be your next assignment. Just describe how the changes would, what should changes to the gas would occur.